I'm building a landscape making Delaunay mesh, and I thought I would film it for my own edification. Maybe some people will be interested by this. So the concept's quite easy. Is we have lines, and I've added an elevation property to them, like 5 meters, 3 meters, 7 and 9, so falling by 2 meters with an odd index. And then what we're doing is we grab these features and we pass them to this identity to wrap them up in a list. We put them into the map, and we use this array function to add a point every 16 feet. And I don't know why I'm in feet. I believe I can turn myself into meters, units, meters, save. Oh, good. Oh, that worked. All right, so we're back in meters. I created this project in the US, which is why Giraffe was like, oh yeah, feet, leaving me stranded. Okay, so now I've got this huge array of points, and every point should have inherited from its parents its elevation. Right. So now what I'm going to do is I'm going to go to an old function, this horrendous jaguar function I have, which what it does is it takes a bunch of points and it forward projects them, and then inside of the JavaScript I got this Delaunay mesh library, and then I create a mesh, create triangular mesh, where we set the Z equal to the height at some point. Let me just see if I can find height. So this is a column making function. Okay, there we go. So convert to Delaunay format 3D, item.geometry x, item.geometry y, item.properties.height. Okay, and this we then convert to Delaunay. Create triangular mesh. This function. Create triangular mesh. Okay, reads in the points, the data array. All right, and we just call that on args. Okay, so we pass this big list of points that have to have properties.height, and then the rest, as they say, is history. Okay, I'll show you what this thing actually does. Roof, museum roof. This is more of an architectural mesh. Okay, so it's here. Okay, there. So what's going on, the function I'm copying is this museum roof, right? And it's doing this Delaunay. So you can see as I move these points around, it's solving for a Delaunay triangulation. And a Delaunay triangulation is, it's just a triangle. You convert points into triangles. And I think there's one rule, which is that the triangles are minimally pointy. So you can see here, this triangle is not as pointy as there's like to triangulate these 4 points can be triangulated like this, or the way they're triangulated. And I think this triangle here is more shardy, more of a point than these 2 triangles. So there's some rule there. And it's just it's a very widely used function. Like in Rhino and Grasshopper use it all the time. It's very fast. It works really nice, very robust. So what I'm doing is, I created this as like an architectural pavilion maker, where I can edit these heights, and I'm generating these columns, and it's quite fun. It's kind of got that 60s utopian architecture feel, maybe a bit too angular. If there was a bit more catenary, it would feel better. But I'm going to use the same function to create the landscape, because this is just a surface. And the function is actually too much, because the function creates this extrusion, which I don't think I will create, and it also creates these trumpet-shaped columns, which we also definitely don't need. So that is this whole lump of code that I am showing you over wherever it is over here. That's this, right? That's what this is doing. And this minified code over here is from a library. And this, I think, you know, there you go. This is like if the Delaunay conditions, which is P1, is inside the circumcircle of P0. Let the reader understand. Yeah, it's trivially true, as is trivial. When I used to study maths, you know, it trivially follows that blah, blah. You'd be like, what? Trivially? Okay, so first I think well, let's actually just copy this across into the other function. And I want to see if this works. So I'm just going to copy so we need a forward projected map. Then it's going to go like this. This is the key bit we need. Then it gets written to mesh. So I'm going to copy the code, the evaluate JavaScript, the map over the forward project, one thing back and one thing forward. Okay, so copy to clipboard. Then I'm going to come to this one and I'm going to paste. Oh, you are kidding. That is a delight. All right, so it doesn't quite keep the connections. That's fine. The args are going to be these args, which we need to do this on. Okay, so this looks like a list of lists. So I think we've got a flatten list. I'm going to do this. There we go. Now we've got this flat list of points. Now the reason it's a list of lists is because for every single line, there's a list of points. So this returns an array of points and it returns an array of points 4 times. So there's 4 times an array of points. So we just flatten those down. And what we should do, now remember each point has this elevation. So what we're going to do is we're going to update this JavaScript to, instead of refer to the properties.height parameter, we'll refer to the properties.elevation parameter. And then we're going to delete the columns, etc. And so it's just going to be a little bit of a mission to figure which bits are which. And then we'll write to this thing, we'll write this mesh. And then we will write the entire feature. And this should work. Okay. So let us get to deleting. Okay, so we go past all the way past Delaunay. All of this stuff is critical to make the Delaunay function work, and then I've got this stuff here. Okay, so the convert to Delaunay format, you can see it goes properties.height. So first thing we're going to do is change that to elevation. Okay, so now our data structure will work. Right, now this is add columns with varying segments. So we can certainly delete this. So where is... when you do this, and that is funny. All right, why am I laughing? Why is it funny? It's funny because it literally worked. I was worried about this extrusion because I thought it would be too steep. Sorry, too computationally intensive, but it literally happened in the blink of an eye. And we were using the right tool. All right, well, that's freaking amazing. So what did I just do? I deleted a function that created the columns, and I just left I left the rest well enough alone, and I changed the property from height to elevation. So now what I want to do is, the weakness with the Delaunay algorithm is it makes these, I think, convex hulls. There's never a concave surface in a Delaunay, so there's never something like this, because it'll triangulate like this. So what that means is if you're doing a contour, you need at least one contour out the back, if that makes sense. Now I am confused. Which one have we forgotten? Oh, I've just copied everything. Okay, so we don't want to copy this one twice because this one is the host. So I want to copy the other ones. Okay, all right. And one of the annoying things about copy in Giraffe is when you copy something, you actually move the original and leave the copy behind you. So I'm going to do this one. So we need, so because we are going to have a convex, we need our site to be completely surrounded. Like the contours need to extend outside of our site, so that all this rubbish, which is not accurate, happens away from us. All right, and so we'll copy this boy. And just like before, there we go. So let's say this is sort of how these contours work. Okay, so this should have an elevation of 1, and this should have an elevation of 11. And then what we need to do is we need to read them in. Now, order doesn't matter for Delaunay because the closest points go together no matter what. So now I will pick that guy, boink, and I will, I will grab the host again, and I'll pick that guy. Okay, I am extremely satisfied with that. Turn the opacity down. Okay. And what I want to do is to prove to myself that I am indeed capturing something. Let me do something like this so that we get a very steep slope somewhere. Maybe let's make it steep over here. So there's like a wall here. There we go. And then the field is very flat, so it's obvious that it's obvious that it's at grade. There we go. I mean, this is absolutely amazing. I used to do this in Rhino all the time. Look at it. It's so beautiful. And what we can do is normally when the surveyors come, they put the contours at the right, but we can actually lift this thing's elevation up to 7. So we have 2 7 contours. So the field itself is now perfectly at grade. There's literally, I don't think there's a limit here. Let's see what happens when contours overlap. Can we get a cave? No, we get a very strange, yes, we can't get a cave. But we get quite a powerful little terrain editor.